This video is going to walk you through the steps of how to write equations from word problems. So our learning target today is I can write an equation using a variable to represent an unknown quantity. That just means that we're going to write an equation after we read the word problem and use the variable to represent the part that we're looking for, the part that we're trying to solve. This is going to look a little bit different than when you just solved word problems in the past. This time we're going to focus on what is happening in the problem and then write an equation based on the context of the problem and the situation of the problem. So I'm going to walk you through the steps one by one to really help you understand how we write equations in algebra. So problem number one. Problem number one says, Mrs. Saul read some pages in her Harry Potter book on Tuesday. On Wednesday, she read 39 pages. If Mrs. Saul read 94 pages altogether, how many pages did she read on Tuesday? You might be thinking this is a pretty simple problem, something that I can solve, on paper, and I probably would have been able to figure this out in third grade. But this time, we're actually just going to write an equation that represents this problem. So we're going to start by deciding what operation we're going to use. And in this case, we're actually going to use addition. And we're using addition because on Tuesday, if Mrs. Saul read some pages, and then on Wednesday, she read some more, which was 39, then that means she read a total of 94. So we took Tuesday's pages, we added some pages of 39, and now we have 94. So the next thing we need to decide is the variable. The variable is going to be whatever number you don't know from this problem. And in this case, I don't know the number of pages she read on Tuesday. So in that case, the variable is going to be t, which is going to represent the number of pages she read on Tuesday. In order to write our equation, the next thing we need to decide on are the constants. The constants, remember, are the values that you do know. And in this case, we know 39, which is the number of pages she read on Wednesday, and 94, which is the number of pages read altogether. The last step in writing any equation is to actually take the variable and the constants and the operation we decided on and write our equation. So like we said, we're using addition. Our variable is t, which is the number she read on Tuesday. Our constants are 39 and 94. So when we write the equation, we're going to take t, we're going to add 39 to it, and that equals 94. And the reason why we write it like this is because since t represents the number of pages she read on Tuesday, that's where she started. She read some pages on Tuesday. Then on Wednesday, she added 39 more pages to that to get a total of 94. So we would write it in this order because, this is the situation in the problem. However, this is not the only correct answer. This is the best answer, the best equation to represent what's going on in this problem. But as you've learned in the past, there are such things called fact families. And fact families mean that you can write 3 other equations that go along with this. And that is 39 plus t equals 94. And then you can take 94 and 39 and subtract them and get t. And you can take 94 minus t equals 39. In any of those equations, you will find that t has the same value. And that value is 55. But we're not as concerned right now in solving for the variable. We're just focusing on finding the equation or writing the equation to represent the situation. And again, the best equation to represent this situation was t plus 39 equals 94. This is part 2 of our 4-part lesson on writing equations from word problems. And again, our learning target is I can write an equation using a variable to represent an unknown quantity. I will walk you through the steps of writing equations from word problems and then also give you some ideas on other equations that would go with that word problem. This lesson just focuses on walking you through the steps of writing the best equation, and then I'll show you the other word problems that also, or the other equations that would also match that word problem. So let's look at our next example. Mrs. Saul buys 105 pencils to last her class the rest of the year. Her students use some of them. At the end of the week, there are only 37 pencils left. How many pencils did Mrs. Saul's students use this week? Now, thinking about this problem, we have 105 to start with, and we only have 37 left. And you probably know immediately how to find the answer, but we're again focusing on writing the equation with a variable that would represent the situation. So let's start by deciding what the operation would be. Because this is a problem where we start with some and we end up with fewer, then we know this is a subtraction problem. Because we start with 105 and we only have 37 left, so that means that some pencils were taken away. Now let's decide what the variable is. The variable is whatever number is the unknown in this problem, or the quantity that I'm trying to find. And in this case, we're going to use P as our variable, and that represents the number of pencils used this week. Because the question in this problem is, how many pencils did Mrs. Saul's students use this week? So we're going to use P. The next thing we need to decide on are the constants. What are the numbers that we already know? And those are the numbers that are going to help us solve this problem. And in this case, we know 105, which is the number of pencils Mrs. Saul bought, and we know 37, which is the number of pencils left. So now the last step is we need to decide on the equation. Because we know that Mrs. Saul started with 105, that should probably be the first number in our problem. And because we know she ends with 37, whatever we have will probably equal 37. So the best equation for this problem is 105 minus P equals 37. That means she started with 105 pencils. Her students used some. We don't know how many they used. They took away P pencils, and she's left with 37. Now, there are other equations that would also match this problem and would end up with the same value for P, as discussed before in a previous video, and that is based on what goes along with the fact families. Usually if we're doing subtraction, we'll have 2 subtraction problems and then 2 addition problems. So the other equations that match this situation and would give you the same value of P are 105 minus 37 equals P, which is probably how you would solve the problem, earlier without thinking about the fact that you would have P as a variable. And then also P plus 37 equals 105, 37 plus P equals 105. All of those equations would give you the same value for P, which is 68. But again, we're just focusing on writing the equation to match the situation and not as focused on finding the value of P. Now, again, the best example or the best equation for this problem is 105 minus P equals 37, because that's what's going on in the problem. That's one that matches the situation. But the rest of the equations are correct as well. So it's important to recognize that all 4 of those equations would give you the same value for P. Welcome to part 3 of our 4-part lesson on writing equations from word problems. Our learning target remains the same, which is I can write an equation using a variable to represent an unknown quantity. And the next 2 examples we're going to do are going to be a little bit more challenging than the ones you saw previously. So let's look at the next example. Hermione and Ginny are coloring in their coloring book. Hermione colors some pages in one day. Ginny colors 3 times as many pages. If Ginny colored 12 pages, how many pages did Hermione color? So you see the 3 times as many, and automatically you probably know that we're going to do multiplication. Now, it's important to pay attention, though, to which numbers we're going to multiply and which number is going to be our answer, because we might automatically want to do 3 times 12, and in this case, that won't be correct. So let's find out why. Our variable is going to be the whatever value we don't know. And the value we don't know is the number of pages Hermione colored. So we're going to use H to represent that unknown amount. The next thing we need to decide on are our constants. There are 2 numbers we do know in this problem, and that's 3 and 12. 3 is represents that Ginny colored 3 times as many. 12 represents the number of pages Ginny colored in total. And this is where we have to think about who colored more pages. Because we know Ginny colored 3 times as many, we also know how many she colored. Then Hermione, the number of pages Hermione colored is going to need to be smaller. And that's why in this case, 3 times 12 doesn't make sense, because Ginny colored 3 times as many pages as Hermione. Which means when we're writing our equation, we're actually going to multiply 3 times h. Remember, when you write a number next to a variable like that, that means 3 times h and not 3. And then if whatever we find that h to represent, we don't just put that number next to it and call it that whatever number it looks like, or 34 is what it would be. Instead, this means 3 times h. So 3 times h equals 12. And the other equations you can write with this would be h times 3 equals 12, 12 divided by 3 equals h, and 12 divided by h equals 3. And like I said before, no matter what, any of those equations, you'll find that h is going to be equal to 4. And again, if we look back at the problem, that actually makes the most sense, because since Ginny colored 3 times as many pages as Hermione, that means Hermione colored fewer. So if you found h to be 36 and you checked back in the problem, you would realize that 36 is unreasonable. So in this case, we have to do 3 times h equals 12 as the best equation, or any of those other equations would be correct as well. Welcome to the final part of our 4-part lesson on writing equations from word problems. The learning target again is I can write an equation using a variable to represent an unknown quantity. Now let's look at the last problem we're going to go over together. That is, Harry Potter and the Sorcerer's Stone is 309 pages long. If Mrs. Saul plans to read 18 pages per day, how many days will it take her to finish the book? So let's start by deciding on an operation. Now you might be thinking that you could use multiplication for this problem, and that is true, but I'm going to use division because I know how many pages I start with, and that way I can divide that number by another number. Let's decide on our variable. What is it that we don't know in this problem? What is the unknown? And in this case, the unknown is D, which represents the number of days it's going to take to finish the book. The next thing we need to look at are our constants. What numbers do we know? Well, in this case, I know 309 pages and I know 18 pages per day. So 309 is the number of pages in the book. 18 is the number of pages read per day. The final step is deciding on the equation. Now, this part is the part that could be the trickiest part. It's the trickiest part because division problems, division equations with algebra are always the most challenging to write, I've found. But the one that I wrote is 309 divided by 18 equals D. And the reason why I wrote that equation is because there are 309 pages in a book, and I've already decided that I'm going to read 18 pages per day. So I'm going to take the 309, I'm going to divide it by 18 pages per day, and I'm going to get D. Now, there are other equations you could write that would represent this problem. I think that the 2 division equations really are the best ones here. 309 divided by 18 equals D, or 309 divided by D, which is the number of days to finish the book, equals 18. Either of those are really correct. And the last 2 equations, the 2 multiplication equations, are also correct. You're taking 18, you're multiplying it by the number of days, and you should get 309, or D times 18 equals 309. Now, if you were using a calculator to find this answer, to find out what D is equal to, you are going to get a decimal number, and it's 17.16666, and the 6's repeat. That means that Mrs. Saul is going to need a little bit more than 17 days to read the book, which is why the multiplication problems are a little bit trickier to look at, because it's hard to decide what you need to multiply that by. And in order to find the variable, you're probably going to use division anyway. But the answer to this would be 18 days, because 17 days wouldn't be quite enough. She needs a little bit more on the 18th day. But again, we don't worry as much about solving for the variable in these equations. We're just focusing on writing the equations with the variable. So either of the division equations I feel are the best answers, but the multiplication divisions aren't incorrect. So thank you for watching these videos. Hopefully this gave you some insight into how to write equations from word problems, and we will continue to work on this.